Hello again, it's me, Mr. Morris. We are working through Summer Homework, Chapter 3, looking at number 33 on that homework. It says the reaction of ethane gas with chlorine gas produces C2H5Cl as its main product along with HCl. Okay, so those are the main products. It says in addition, the reaction invariably produces a variety of other minor products, including C2H4Cl2, C2H3Cl2, Cl3, and others. Okay, so those are, don't be too distracted by that. Those minor products, basically, those don't have to be put in the equation. It's saying that that chemical reaction we're talking about, it could produce what we want to produce. It could also take a different chemical reaction. So you don't need to worry about that when you're writing out the chemical equation. It's just going to be the major products. Naturally, the production of these minor products reduces the yield of the main product. Calculate the percent yield of C2H5Cl. If the reaction of 300 grams, it's 300 with a decimal, 3 sig figs, of ethane with 650 grams of chlorine produced 490 grams of C2H5Cl. Now, if I am looking for the percent yield, which is what it's asking me, I first need to know the actual yield and the theoretical yield. What's given in the problem is the actual yield. I need to find out what the theoretical yield is. I'm given two reactants, so that tells me this is a limiting reactant problem. I don't have a chemical reaction yet, so we need to start with that. Okay, it says the reaction of ethane gas, and that's the other thing, this word ethane, we need to connect that. Ethane is C2H6. So I'm going to say ethane, C2H6 reacts with chlorine gas plus Cl. Don't forget that chlorine is one of our diatomics, so it's Cl2. You need to remember that. If you haven't memorized those yet, you need to put the diatomics to memory. They make a 7 on the periodic table. Go to 7, make a 7, so it's hydrogen, plus if you go to element number 7, that's nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Go to 7, make a 7. That's our diatomics. They produce C2H5Cl as the main product along with HCl. And then the next thing says a bunch of minor products. Okay, let's check and see if our equation balances. I have 2 carbons. I have 6 hydrogen on this side. Over here I have 5 and then 6. Chlorine, Cl2. I've got 1 chlorine and I've got another chlorine. So it's already balanced. The coefficient for each of these is just going to be 1. Okay, so let's get started with the numbers. Okay, I have 300 grams and 650 grams. Well, in order to really do anything with those numbers, we first have to turn them into moles. Okay. Not a lot of room to work right here, so I'm going to write it down here. Start with our ethane. 300 grams of ethane, which is C2H6. 1 mole over the molar mass, and I'm going to find that real quick. I'll find the molar mass for both of them. So 300 grams of C2H6, we're going to multiply that by 1 mole over 30.07 grams. That's the molar mass of C2H6. 650 grams of Cl2, chlorine, times 1 mole of Cl2 over 70.906 grams of Cl2. That's the molar mass of Cl2. See what we get when we put those in the calculator. 300 times 1 over 30.07, 9.98 for 3 sig figs, 9.98 moles. don't forget to label what it is, moles of C2H6, because we're going to need to know which one to put it above. And we've got Cl2, 650 times 1 over 70.906, 9.17. 9.17 moles of Cl2. All right, now we've got moles, we can put that in up here. I'm going to say I've got 9.98 moles over, well, the coefficients we said are all 1, so that's going to be 1 mole. For Cl2, we're going to put 9.17 moles over 1 mole. Now you maybe could just figure out by looking at it which one's going to be the limiting reactant, but it's important that we show our work so that especially when you're taking the College Board exam, you want to be able to explain in your writing exactly what you're doing so they know that you're solving it correctly. So we're going to put 9.98 moles of C2H6 over 1 mole C2H6 equals 9.98. And you could say batches or moles of reaction would be a correct unit, or you can leave it unitless. 9.17 moles Cl2 over 1 mole Cl2. Get 9.17 moles of reaction, batches, or just no unit. Any of those are fine. Okay, now we want to make a little line here because I'm switching over to the other side. I want to use my limiting reactant on the other side, so let's go ahead and choose that. The one that gives you the smaller answer out of these two is going to be your limiting reactant. So chlorine was my limiting reactant. I'm going to use it on the other side when I'm trying to find what I'm looking for. I want to find the percent yield of C2H5Cl. So I have 9.17 moles of Cl2 over 1 mole of Cl2 equals, and then my unknown that I'm looking for is C2H5Cl, so it's going to be X moles, and then on the bottom we would say 1 mole because our coefficient is 1. So I've got X moles of C2H5Cl over 1 mole C2H5Cl. You can see that X over 1 is X, X times 1 is X, so and then 9.17 times 1 or divided by 1, any way you look at it, it's 9.17. So X equals 9.17 moles. Let's look at your units of X. It's moles of C2H5Cl. So now what I need to do is I need to convert it to the units that I was given in the problem. What was actually produced is 490 grams of C2H5Cl. If I want to compare them, I need to have the same units. Right now I've got moles. I need to turn that into grams. So we're going to take this 9.17 moles of C2H5Cl. I'm going to turn it into grams by putting 1 mole on the bottom, and then on top we're going to put grams. That's going to be our molar mass, so let's figure out what that is real quick. I get 64.515, and if I punch that in the calculator, I'm going to get 0.17 times 64.515 divided by 1. I get 591.6 82.6, so that rounds to 592. 592 grams of C2H5Cl. Now, this, if I do the math, this is how much I think I can make. This is how much I should be able to make. In other words, it's my theoretical yield. Theoretically, I should be able to make that, but what can I actually make? Well, the actual yield was 490 grams. I want the percent yield. Remember, percent yield is actual over theoretical times 100. So my actual is 490. My theoretical yield is 592. I need to multiply it by 100 to get the correct answer. So now let's figure out what this is. 490 over 592 times 100. I get 82.77, which rounds to 82.9. I think. What did I just say? No, 82.8. I'm sorry. 82.77 rounds to 82.8%. That's our percent yield for this problem.